August 2024. Nantong, Yangtze River. A 270-meter Soviet-era carrier, the Minsk, goes up in flames. Not a missile, not sabotage, a welding torch, and a total lack of discipline. Fire crews from the Shandong Science and Technology Park arrive, and what do they find? A hollowed-out hull, no fire suppression systems, and watertight doors that don't work. That's what wins wars. QC, procedures, maintenance. The Minsk was Beijing's trophy, a decommissioned Kiev-class carrier brought from Soviet wreckage turned ticket booth. But if you can't keep a museum ship from burning down in a calm river, you don't have the foundation to run high-tempo military hardware when the stress is real. Subs, ships, missiles, tanks. When pressure hits, what actually works? While the world watched the South China Sea in May 2024, a major asset quietly vanished under the brown water of the Yangtze at the Wuchang's Shipyard in Wuhan. Not a barge, not a tug. A lead boat of the Type 041 Zhu class, the newest nuclear-powered attack sub in the PLA Navy. Satellite imagery from Planet Labs shows it clearly. Early May, tied up at the pier. Easy to spot, including an X-shaped stern meant to copy ultra-quiet profiles like the American Virginia or British Astute. By late May, the sub is gone, and in its place, 4 massive floating cranes hovering over the water. By July, the cranes move out, and you've got a scarred, dark hull sitting in a dry dock nearby. The reconstruction of this sinking points to a disaster during final outfitting, likely while the boat was running mooring trials with the reactor active at low power. The Zhu class is a hybrid design, using a small nuclear reactor to charge batteries for long underwater endurance. Basically a shortcut to get nuclear capabilities without doing the hard engineering of a true blue water SSN. But the failure mode is the real red flag. When a submarine loses power at the pier, backup systems are supposed to seal the hull and keep it floating. In a professional yard, redundant sensors and a qualified watch team spot a list immediately. At Wuchang, it just slipped under. When cold river water hits a hot reactor vessel, the physics don't care about propaganda. Rapid cooling creates thermal shock, catastrophic brittle fractures in primary cooling loops and potentially the pressure vessel. This doesn't just ding the boat. It effectively totals the nuclear propulsion system before the vessel ever fires a single torpedo. Compare that to the USS Connecticut collision in 2021. A Seawolf-class boat hits an uncharted underwater mountain in the South China Sea at speed. Bow and sonar dome destroyed, combat-like trauma. But the nuclear plant stayed secure. The pressure hull held, and the crew limped that crippled boat across the Pacific to Guam. Connecticut proved survivability under extreme trauma. The Wuchang incident suggests China's newest subs can struggle to survive their own launch parties. And if the newest quiet tech can't reliably survive shipyard conditions, deep water reliability is a gamble. But instead of getting the backbone right, Beijing does what it always does. Go bigger, go louder, go more American. Don't forget when they tried to run Shandong like it's a U.S. carrier. Mid-September, Japan tracks the group operating about 650 kilometers south of Miyako Island in the Philippine Sea, positioned like a real carrier strike group, the kind that's supposed to threaten routes, pressure Taiwan's approaches, and posture toward the wider Pacific. That's the image. We can do what the U.S. does. But the moment you judge a carrier the way the U.S. judges carriers, by output under tempo, the fantasy cracks. Japan's tracking of Shandong's earlier operation showed 620 sorties across the monitoring window, and that includes aircraft and helicopters. The U.S. benchmark isn't a few big deck photos. The Ford class was designed around 160 sorties per day sustained and up to 270 per day surge. Those numbers don't come from hope. They come from how the ship is built. Power, weapons handling, deck cycle, maintenance machine. So when China stages a U.S.-style carrier fight, it's admitting the scoreboard it wants to play on. And on that scoreboard, Shandong isn't a Pier system. It's a training carrier wearing a superpower costume. Because copying the formation is easy. Copying the tempo is the part that takes decades. The reason for this blowout is structural. Shandong uses a ski jump ramp. That physics limitation forces the J-15 to take off with light fuel and weapon loads. A J-15 can't leave the deck with a full anti-ship loadout and enough gas for long-range strike. It has to pick one, or rely on carrier-based aerial refueling that doesn't really exist for them yet. U.S. carriers use steam or electromagnetic catapults. They launch FA-18 Super Hornets and F-35Cs at max weight regardless of wind. On top of that, open-source photos and video have repeatedly caught Liaoning, Shandong's sister ship, pushing thick black exhaust most famously during its Hong Kong arrival on July 7, 2017, when the black smoke footage went viral. Heavy soot like that is a clear sign of incomplete combustion and lousy boiler maintenance. Operationally, the point isn't aesthetics, it's signature. A visible plume that makes a carrier group easier to spot, timestamp, and correlate with other sensor queuing. And for the US, that means you don't need perfect hunting conditions. When a fleet is leaving that kind of signature, you're helping American ISR and undersea forces build and maintain the track. In a fight, you're not just on radar, you're advertising your presence. In mid-December 2025, Fujian, China's newest and most advanced aircraft carrier, was tracked transiting the Taiwan Strait with no visible flight operations, and Taiwan's defense minister said it was presumed the carrier was heading back toward the Shanghai shipbuilding area for maintenance. To launch a heavy jet with an electromagnetic catapult, the deck has to take insane repetitive stress. If a brand new carrier is already cycling back into the repair pipeline before it's even proven a steady ops rhythm, that's a readiness warning, because the metallurgy, coatings, and precision machinery have to survive thousands of repetitive load cycles, not a launch ceremony. In a real fight, Shandong or Fujian risks ending up deck-locked, unable to cycle aircraft fast enough to stop saturation attacks, turning carriers into floating targets instead of power projectors. But the rot isn't just in the water. It runs all the way into missiles and armored hardware. On December 8, 2025, Reuters reported Thai officials worried about Cambodian long-range rockets, including the Chinese-made PHL-03, and Thailand launched airstrikes targeting facilities tied to that threat. Then, late December 2025, viral footage shows a multiple-launch rocket system detonating during a live firing sequence, a catastrophic malfunction caught on camera. Some reports claim it was a Chinese Type 90B, Chinese-made launcher. On May 2025, Pakistan fires Chinese-made export PL-15E, and instead of a clean kill, the story ends with debris reportedly recovered inside India. That's not a victory lap, that's a post-mortem. And Asia Times points to the most likely killer at long range: jamming. Because BVR missiles don't magically lock and win. They write a guidance chain, mid-course queues, data link updates, terminal seeker, and electronic warfare can snap that chain and turn $1 million shot into expensive confetti. China built the PL-15E to rival America's AIM-120 class, but the U.S. missile ecosystem is brutal for one reason: maturity at scale. The AIM-120 isn't just range on paper. It's 14,000 plus built and a documented 16 air-to-air kills, meaning real integration, real training reps, real fuses, real seekers, and real lessons learned under combat pressure. China sells the headline. The U.S. sells the outcome. January 2024. The Rocket Force Purge wasn't rumor anymore. It becomes a pattern. Names, removals, a sweep that started in 2023 and spreads through missile enterprise and defense leadership. By January 6, 2024, Bloomberg reported U.S. intelligence assessments alleging extreme readiness corruption inside China's strategic missile force, including claims that some missiles were filled with water instead of fuel, and silo fields had lid door problems that could prevent launch. Then, as the purge widened, Reuters reported on June 27, 2024, that former defense ministers Li Shangfu and Wei Fenghe were expelled from the Communist Party for corruption, and cases were sent to military prosecutors. You can't launch a rocket if the fuel tank is full of tap water. The U.S. nuclear missile force is built around solid propellant readiness. The Minuteman III ICBM uses 3 solid propellant rocket motors, so there's no fueling window before launch. Readiness is baked into the design. China's force is mixed, but it still relies on liquid propellant legacy ICBMs like the DF-5, a silo-based 2-stage liquid propellant missile that uses UDMH NTO and has been publicly described as requiring 30 to 60 minutes to load. Exactly the kind of fueling chain where logistics discipline matters. If even a few missiles are broken like this, generals have to assume the whole system is bad. In December 2025, Thailand's Chinese-made VT-4 Norinco export tank suffers a serious main gun failure during real operations near the Cambodia border, and the Thai army opens a technical investigation because this wasn't enemy fire. It was the hardware breaking under sustained use. Chinese tanks had major issues. Thai crews operating the VT-4 publicly complained about repeated mechanical failures and design shortcomings during active use. And the hard numbers explain why an autoloader problem is so punishing. The VT-4 is a 3-man tank with 22 rounds in the autoloader, advertised at up to about 8 rounds per minute. So if that loading system or its power feed path fails, you don't just slow down. You can lose your ability to keep the main gun running at tempo. Now put that next to the US approach. The M1 Abrams is built around a 4-man crew with a manual human loader, and that loader also supports maintenance and other crew tasks, which is exactly why the Abrams can keep fighting even when conditions are ugly and systems degrade. Because the loading function isn't trapped inside a single mechanical chain that needs perfect world reliability. US gear is built to survive chaos. China's military might look strong on TV, but it risks falling apart as soon as the first shot is fired. A museum ship burns because basic systems and discipline fail. A new submarine allegedly sinks in a protected shipyard environment. Carrier tempo collapses under the real scoreboard. And hardware reliability, from rockets to missiles to tanks, shows failures that don't care about propaganda. The US military is the gold standard, not because it has the most toys, because the systems keep working when conditions are ugly and the clock is real. Bye for now.